we're looking at the basics of finding the domain and range of functions. So domain is what? Input values, and range is your set of output values. Right? Now, what is the valid input? Valid inputs are inputs that ends up with a particular output. When I tell particular output, it excludes infinity and minus infinity, or imaginary number. What is imaginary number? That is something that you're going to see in the future. So the basic principle or the idea behind this topic is the step 1 and step 2. In the step 1, we are finding any restrictions and then applying it to find the required domain. Okay, so I'll explain this. So we have set of examples or cases. Remember, these are just cases. There are plenty of the restrictions that standard restrictions that we should be knowing. So this is 1, 2, 3, 4, and there is a fifth one. It's over here. Now, so very first thing is rational function. Whenever you get basically in the simplest form, your function ends up with a variable in the denominator. This is what we should do, not do. So the domain of a fraction cannot be equal to 0. Not domain, sorry, denominator. What does it mean? See, 1 by x minus 2 is the simplest form. Clearly, this is a rational function wherein we have an expression in the denominator and we cannot solve it further. The possible values are all the real numbers excluding 2. The question is, why can't I handle 2? Let's substitute, let me use the other color. Let's substitute x is equal to 2. Let's see what happens. So we'll end up with f of 2 is nothing but 1 minus 2 minus 2, which is nothing but 1 by 0, which is nothing but undefined infinity. So this is not a valid input. But any other value, if you guys put 1 minus 2 is minus 1. So overall the result is minus 1. That's okay. You end up with 0.2564. That's also okay. You can end up with any number which has a particular value. That's okay, but not this. So in such a scenario, we have to discourage the system or whatever you guys want looking at. We should discourage that particular value to be not to be part of the whole input values. Okay, right? Next thing, we're looking at square root. When it comes to square root, what is the domain? Yes, the domain is, can you guess? All the positive real numbers including 0. Right? The reason being, if I take square root of minus 5, what is this? This is nothing but I root of 5. Right? Oh yeah, sorry, you guys don't know this. So this is nothing but imaginary numbers. Okay, yes, this is imaginary numbers. If I take up square root of any negative number, I end up with something called as imaginary numbers. So square root cannot have an input of negative number is the funda. Next one is logarithm function. Here too is the same thing. Here too we are looking at real numbers including 0. And next up we have inverse trigonometric function wherein the domain is minus 1 to 1. Again, all of this you will understand in time. For now, I'm just exposing you guys to the methodology or few facts. You have seen modulus function. That is, it takes up any input value and gives an output of positive number. So here the domain will not, it is not restricted. We can give pretty much anything. Minus 3.4, 0, 6, doesn't matter. So it can handle all the inputs. Now, once you know restriction on any given function, if there are none, it's okay. If there are, how is that we have to handle? Like square root. It has a restriction. We can't have a square root of negative number. Remember, that's a restriction. Right? So with this, we start off with, okay, just a second. So we're starting off with the domain. So what is that we're looking at? See, this is a square root of a expression. So we start off with talking about that. We know that root, actually square root, not just root, square root of an expression should be equal to or greater than 0. That is, square root of x minus 4 should be greater than or equal to 0. Okay, so this you guys know as inequality, right? These are your inequality symbol. The topic is called as inequality. How do you solve it is something that is again a separate chapter altogether, but yeah, it's not that hard. So for further simplification, what will I do? Now we'll look into simplifying for x. So this is your next topic. So once we get the basic restriction in place, then we need to simplify for x. Okay, so this can be step 2b. Anyways, further it's a continuation. So whenever you get square root, how do you simplify this? We'll start off with squaring both ends, both sides. So we have x minus 4 greater than or equal to 0. And then we have x is greater than or equal to, oh yeah, sorry. Let me do it stepwise. Now, how do we further solve it? We should be adding 4 both sides. And so we have x is greater than, sorry, x minus 4 plus 4 greater than or equal to 0 plus 4. And so we have minus 4 plus 4 getting cancelled. X is greater than or equal to 4. And that is our valid input values. So let me take case study. So we have f of x is equal to square root of x minus 4. Let's substitute x is equal to 2. And now we have f of 2 being equated to 2 minus 4, which is square root of minus 2, which is not a real number, right? It does not belong to real number. Thus, it's not a valid input. Okay, guys. So such is your nature of solving, or this is what you have to do basically. Okay, guys. Yeah. Please see to that you don't miss anything. Make your own running note. Don't worry, all of this solving inequalities, everything will be learnt in time. And the idea of something called as imaginary numbers is again a separate topic. That too we will be learning.